SO2, also known as sulfur dioxide, is mainly used in winemaking businesses to prevent the oxidation in the wine and the formation of microorganisms. When SO2 is added to wine, it combines with some of the wine components such as acetaldehyde, and this renders it inactive, known as bound SO2. The level of activity of the uncombined sulfur dioxide, free SO2, is affected by the pH of the wine. The more acid, the more acidic the wine is, the more active it is. Due to health concerns such as asthmatics and so as to encourage quality winemaking, the use of SO2 is strictly controlled. Sweet wines are higher, while organic wines are required to have even more lower levels. Levels of the SO2 concentration are usually increased according to the style of wine required. It preserves primary aromas, sanitary state of grapes, especially the level of grape rot, and pH. The high pH, low acid wines need more SO2. When adding, it is important to make sure that it is well mixed in. Ascorbics and vitamin C can effectively supplement the antioxidant role of SO2. But this cannot replace SO2 completely, as it has no antiseptic effect. As a result, the overconcentration of SO2 in winemaking businesses can lead to many health concerns that the owners need to be concerned about.
Hey guys, it's me, David, on my couch, here today to tell you how useful gas is in your everyday life. Okay, so today I'll be talking about two very well-known gases, nitrogen and hydrogen. Let's get something clear. Hydrogen does not occur naturally. The hydrogen we'll be using is mainly harvested from methane. And now that we know where both gases come from, we can put them through a reaction called the Haber process, named after Fritz Haber and Carl Bosch. Okay, so basically, during the Haber process, certain conditions need to be met. It needs to be at 200 times normal atmospheric pressure and between 400 and 450 degrees Celsius. And at that temperature and pressure, the hydrogen and nitrogen will combine to create ammonia in a gaseous state. And when it comes back down to room temperature, it becomes a liquid. And now that we know where both gases come from, we can put them through a reaction called the Haber process, named after Fritz Haber and Carl Bosch. Okay, so basically, during the Haber process, certain conditions need to be met. It needs to be at 200 times normal atmospheric pressure and between 400 and 450 degrees Celsius. And at that temperature and pressure, the hydrogen and nitrogen will combine to create ammonia in a gaseous state. And when it comes back down to room temperature, it becomes a liquid. Now that we have ammonia, we can create many different types of products. For example, ammonia is used to make fertilizer for agriculture, explosives for the military, and Windex to clean your windows. You see, with these gases, nitrogen and hydrogen, we're able to create ammonia, which is very useful in your everyday life. And that concludes this segment. Off to you, Vishnu.
David, what are you doing? We have to go freshen you up.
Alright, let's go.
Gotta get in there. They're all done.
Wow, dude, that was incredible. How radical. How do you get so much hairspray into that small bottle?
Dude, it's not all hairspray. It's two different fluids.
What do you mean?
There's one fluid called a product and another fluid called a propellant.
So half-half?
Yeah, basically it's half-half.
It's a ripoff.
No. See, without the propellant, the hairspray can't become a gas.
What are you talking about? What is this? Science?
Alright, so inside this can,
Yeah?
it's not 1 atmospheric pressure, which is the one we're in right now.
Okay.
It's actually 8 times that.
Oh my god. Yeah?
So what that does is the propellant was a gas, but it was pressurized into a liquid.
Okay.
And it mixes with the content of the hairspray. When the propellant comes out of the hairspray, it goes back into being a gas.
Wow! Isn't that just dandy?
It's so cool.
Yeah, isn't that cool, guys? That's cool.
Yeah.
Hey, what's up, you guys? Today I'm here to talk to you about fire extinguishers on David's couch. Holy, can you see? Okay. All fire extinguishers at the bottom of the can are filled with a fire suppressant, and at the top of the can there is a glass bottle filled with a compressed gas. When the plunger is pressed down, then the glass bottle breaks and the gas is released. Due to the difference in pressure, both the gas and the fire suppressant are released and pushed through the nozzle. There are three main types of fire extinguishers. The first one is a water fire extinguisher, which is mostly used for fires involving wood or paper. The second type is a dry chemical fire extinguisher, and with this fire extinguisher, it releases foam, and this foam releases CO2. The CO2 displaces oxygen in the fire, and the foam can act as an insulator, so it's very good for fighting electrical fires. The third and final fire extinguisher, also the most commonly used one, is the CO2 fire extinguisher.
That's right, guys.
At the bottom of the can, there is sodium bicarbonate, and it's an aqueous solution. At the top of the extinguisher, in the glass bottle, there's sulfuric acid. Once the plunger is pressed and the glass bottle breaks,
You need better lighting, man.
then the acid is released and there is a chemical reaction. And in this reaction, the products are sodium carbonate, water, and CO2. Due to the difference in pressure, all the reactants are sent out the nozzle, and the CO2 displaces the oxygen, and its temperature, which is very cold, takes out the fire. Go away.